Hello and welcome to the Villegas Academy, where we rise by lifting others. Today I will be showing you 3 different functions where you have to meet requirements regarding x-intercept, domain, and range.
Hey Frank.
Let's say you were to graph these different x-intercepts, which was -3, 0, the origin 0, 0, and 1, 0, and lastly 4, 0. Yeah, you have a domain of all real numbers, so if you go from infinity, that's our infinity sign, my bad, to positive infinity. But yeah, you have a range of -6, positive infinity. So you cannot go past -6. So let's find 3 different graphs in order to graph these x-intercepts, but meeting the requirements of the range. So here we have our graph, and in our graph we have the points which were -3, 0, so -3, 0. We have 0, 0, which is the origin, and we have 1, 0, and 4, 0. So how would you graph this in order to land on all these 4 points and yet not be on a domain of on a range of -6? You cannot pass that line. So one way would be using y equals cosine of x. So meaning that when you type in your graphic calculator, you write y cosine, you use a graphing calculator, cosine, and then you put a number, and a graph like this would come out, but you see how the arrows will be pointing downwards. But yet here you can have a -6 as a range, like make sure to have a range of -6. Another way would be y equals sine of x. Same thing, using your graphic calculator, you could put in y equals sine of x, and you would get this type of graph. But you notice that instead of having it downwards, you have it upwards, pointing upwards. And yet it's still meeting the requirements of -6, and it's meeting at the 4 points. Lastly, the absolute value function, which here we see. And in all of these 3 different graphs, they're all different because you see the absolute value looks like a V, pretty much. There's a downwards V, upwards V, and then downwards V again. Here they're like U's kind of, where they're all like a squiggly line, and last it's an upside down U, or like an M, as one would say, and as one would say, this would look like a W. And all these different functions will still meet the requirements of being able to graph these while still intersecting the -3, 0, 0, 0, 1, 0, and 4, 0, with the domain of all real numbers and a range of y is greater than or equal to -6. Thank you for watching my video. Hope you had fun and hope you learned something today.
Okay, bye Frank.